In this video, we're going to look at how to solve a quadratic equation in the form ax squared plus bx plus c equals 0. And that's just a fancy way of saying there are three terms, and it's equal to 0 when you put it together. And the three terms, one has to have an x squared, one has an x, and the other is a number that stands alone. So how do we solve an equation that's in this form? Well, the first thing that we have to do is factor it. There's always a temptation to isolate the x in the same way we would do for a linear equation, but that won't work because we have two different types of terms. We have an x squared and an x here. So we have to factor this equation. So in order to do that, we will have to set up two sets of parentheses, and we have to separate our x squared. So now we have separate, or x squared is separated. One x in one parenthesis and x in the other. Our next step is to look for two numbers that multiply to get our c. In this case, our c is 10, our last number, and add to get our middle number, or b. You want two numbers that multiply to get 10 in this case and add to get 7. You may see that right away, what our two numbers are, but just in case, what we would want to do, well, it's much easier to figure out two numbers that multiply to get 10 than two numbers that add to get 7. So you might want to make a little list and say, okay, we're trying to get two numbers that multiply to get 10. And so you want to just go down the list and check, pair up numbers. So we have 1 and 10 multiply to get 10. However, they don't add to get 7, so you would cross that off. Then go up the list to 2, and 2 matches with 5, because those two numbers multiply to get 10. And when you check if they add to get 7, they do. 2 and 5 do give you 7 when you add them up. So those are the two numbers that we're looking for. So in this case, in our parenthesis, we would have plus 2, that's the first number we had over there, and plus 5. Now, that will give us, if we were to multiply everything out, first, outer, inner, last, FOIL, first, outer, inner, last, that would give you your original. We're not going to do that, but that's a great way to check if you are correct. And in this case, we are. So now we're ready to finish the problem. We have two numbers that are being multiplied, or two numbers are x plus 2 and x plus 5. And we're being told that when these numbers are multiplied, our answer is 0. So one of those numbers have to be equal to 0. So either x plus 2 is 0 or x plus 5 is 0. And now that becomes very easy to solve, because both of them are now linear equations. We can subtract 2 from both sides to isolate the x in this case, and we get that x is equal to -2. And on the other side, we can subtract 5 from both to isolate the x, and we get that x is equal to -5. Both are our answers. So in many quadratic equations, you will end up having two answers. Let's look at another example. Okay, so in this example, we have something slightly more difficult, but only slightly. There's a negative sign there. So now we have to pay closer attention to what's happening with our signs. So we're still looking for two numbers that multiply to our c, our last number. But in this case, our last number is negative. We're looking for two numbers that multiply to give us -27. And our two numbers will add to give us +6. If you see it right away, great. If not, you might want to pair up your numbers. So we can have 1 and 27. One of those numbers, of course, would have to be negative in order to multiply to get -27. But there is no way that 1 and 27, even if any of them are negative, will give us 6. So that's not our pair that we're looking for. 2, we can now factor our expression. So of course we separate the x's as we did before, and on one side we have our minus 3 and on the other side we have our plus 9. We have two numbers being multiplied and the answer will give us 0. So either x minus 3 is 0 or x plus 9 is 0. Which means that x is equal to, if you isolate the x on the left side, you get x is 3 or x is negative 9. And we have both our answers. Okay, so this example looks a lot different because it's not equal to 0. But it is still a quadratic and we still have no number in front of our x squared, which means that there is an invisible 1 right there. So we could still do the same thing. We just have to do one step before. And that is make our equation equal to 0. So now what we'll have on our left side is that x squared minus x minus 30 is equal to 0. Now it looks a lot like what our two previous equations looked like. So again, we're looking for two numbers that multiply to give us negative 30, and again, pay attention to the signs, and add to give us negative. In this case, there is no number in front of that x, which means there's another invisible 1 right here. So add to give us negative 1. And if you don't see it right away, we can start pairing off numbers. 1 with 30. One of them would have to be negative to give you our negative there, but there's no way to add to negative 1 with those two numbers, so we keep going. 2 and 15. Again, no way to add those two numbers, even if one of them is negative, to get negative 1, so we keep going. 3 and 10 also doesn't work, but don't give up. 4 gives you a decimal if you try to divide into 30. 5 and 6 multiply to get negative 30 if one of them is negative. And if our 6 is negative, when you add it up, you'll get negative 1. So we've found our pair. So now we can factor our equation or expression. X plus 5, x minus 6 will give us 0, which means that x is negative 5 or x is 6. Finally, we're looking at something that looks even more different than the last question we did. I already said that this video was about expressions in which or a is equal to 1. So why would I throw this into this video? Well, we can make this an expression with a equals to 1. First, the first thing you always want to check when you have a number in front of your x squared, you want to check if there's a common factor, meaning, is there a number that can go into all of our values a, b, and c? In this case, we do have a number that is common, a common factor to 2, 12, and negative 32, and that value is 2. So we can actually take out that common factor. Now we have to go through and divide each of our terms by 2. So 2x squared divided by 2 will give you just x squared. 12x divided by 2 will give us 6x. And negative 32 divided by 2 gives us negative 16. So now this looks a lot like what we're used to. So now we can factor by looking for the two numbers that multiply to get negative 16 and add to get 6. And our two numbers should be plus 8 and minus 2. So it's x plus 8 and x minus 2, and that's equal to 0, which gives us that x is negative 8 and x is 2. As far as this number out here, well, that cannot be equal to 0 because it's 2, clearly. So we can ignore it at the end, and those are our answers.